March 2025. A high-altitude lake in a remote mountain range, more than 3,000 metres above sea level, 40 kilometres from the nearest road. A local researcher hauls a net through cold, dark water. Something thrashes inside it. Something with armoured scales, lobed fins, and a body plan that hasn't changed in 400 million years. This fish was declared extinct in 1946. So why did it just turn up alive in a mountain lake that no coelacanth has any business being in? The researcher grabbed a photograph, then made a satellite call, and within hours a scientific community that had written this animal off 79 years ago was scrambling for answers it still doesn't fully have. I'm your host, and what you're about to hear is the full arc of one of the most improbable comebacks in the history of natural science. Not a comeback engineered by conservation programs or captive breeding. A comeback that happened in secret, in the dark, while the rest of the world moved on. To understand why that 2025 discovery hit so hard, you need to understand what a coelacanth actually is. These are lobe-finned fish, members of the class Sarcopterygiae, and they are more closely related to lungfish and to us than they are to most fish swimming in the ocean right now. Their fossil record stretches back 400 million years. They survived 3 separate mass extinctions. When the asteroid hit 66 million years ago and erased the non-avian dinosaurs, coelacanths were in the water. And then, somewhere around that same boundary, they vanished from the fossil record entirely. They have no true spine, instead a hollow notochord, a structure so ancient it predates bone as we understand it. They carry a rostral organ in their snout, packed with electrosensory cells for detecting prey in total darkness. Every anatomical feature points to a lineage that solved the problem of survival hundreds of millions of years ago and simply never needed to change. By the early 20th century, every textbook on Earth listed them as extinct, not endangered, not rare, extinct. A ghost in the geological record, preserved in stone but gone from the living world. Scientists weren't guessing. The evidence was overwhelming and the consensus was unanimous. Then something happened in 1938 that should have rewritten everything. And what came after that discovery set up the question we're still trying to answer in 2025. Because this fish didn't just survive once against impossible odds. It may have done it twice. It was 1938, and Marjorie Courtenay-Latimer was doing what she always did on quiet December mornings, keeping an eye on the docks at East London Harbour, on the southeastern coast of South Africa, waiting to see what the trawlers brought in. She was 32 years old, and the curator of a small, underfunded natural history museum in a port town that most of the scientific world had never heard of. She had no formal university degree in science. What she had instead was an almost compulsive eye for the unusual, a habit of turning up at the harbour whenever Captain Hendrik Goosen's trawler came back to port, and a standing arrangement with the crew to call her if anything strange surfaced in the nets. On the 22nd of December, Goosen called. The day was brutal. South African midsummer, the kind of heat that turns the air above the harbour into a shimmer. The smell of salt and fish and diesel baking together into something close to unbearable. Courtenay-Latimer pushed through the pile of rays and sharks and common trawl species covering the deck, and then she stopped. Buried under the catch, almost hidden, was a fish unlike anything she had seen before. Roughly 1.5 metres long, close to 60 kilograms. Its scales were a deep, iridescent blue, fading towards steel grey, armoured and thick like overlapping shields. But the thing that stopped her cold was the fins. They weren't arranged like normal fish fins. They were fleshy, lobed. They jutted from the body on thick, muscular stalks, almost like the suggestion of limbs. The fish looked, she would later write, like something from another world. She had no idea what it was. But she knew with absolute certainty that it mattered. Here is where the story becomes a race against the heat. There was no refrigeration available at the museum. It was the height of summer. The fish was already beginning to turn. Courtenay Latimer made a careful sketch, the kind of drawing that would later prove invaluable, and she wrapped the specimen in cloth and hauled it across the city to the only person she could think of who might help preserve it, a local taxidermist. The soft internal organs were lost to decomposition before anything could be done. That was only round one. The fight to save what remained, and then to get anyone in the scientific world to believe what she had found, was just beginning. She wrote a letter. She sent it, along with her sketch and a careful description, to the one ichthyologist she trusted, Professor J. L. B. Smith at Rhodes University, several hundred kilometres away. Then she waited. The weeks that followed were agonizing in the particular way that waiting is agonizing when you know something enormous is sitting just out of reach. Smith was not an easy man to impress. He was meticulous, rigorous, the kind of scientist who treated extraordinary claims with cold suspicion. He looked at Courtenay Latimer's sketch. He read her description of those lobed, fleshy fins, the heavy armoured scales, the body plan that matched nothing in the modern record. His reply contained a sentence that has been quoted in biology classrooms ever since. "I would not have believed it possible," Smith wrote, because what Courtenay Latimer had pulled from the bottom of the Indian Ocean was a coelacanth, a fish that the entire scientific establishment had agreed with considerable confidence had been extinct for 65 million years. The coelacanths had a fossil record going back more than 400 million years. They had been abundant, diverse, widespread. And then, at the end of the Cretaceous, the same extinction event that erased the non-avian dinosaurs had apparently taken the coelacanths with it. 65 million years of absence from the fossil record. The scientific consensus was not a guess. It was built on an enormous body of evidence, and everyone who had looked at that evidence had reached the same conclusion. Courtenay Latimer's fish was named Latimeria shallamni in her honour. It was described almost immediately as the most significant zoological discovery of the 20th century. A living fossil, a ghost from deep time, somehow still breathing. Marjorie Courtenay Latimer would later wish she'd made a different call about preservation, that she had found a way to keep the internal organs intact rather than surrendering the specimen to a taxidermist. The soft tissue that was lost might have answered questions that took decades more to resolve, but she had worked with what she had, in the heat, with no resources and no warning, and she had saved enough. The mounted specimen went on display. The scientific world erupted. And then slowly a different and more uncomfortable question began to surface. One specimen was extraordinary. One specimen was a miracle, possibly a stray that had wandered far from wherever its kind actually lived, if its kind existed at all. The find proved that coelacanths had survived into the modern era. It did not prove that a population existed. It did not tell anyone where to look. That's not a typo, by the way. There really was just the one fish for 14 years. One mounted coelacanth in a South African museum, and an entire planet's worth of ocean in which to search for another. The search that J. L. B. Smith launched after 1938 was, by any reasonable measure, one of the most sustained and obsessive scientific hunts of the 20th century. He had the mounted specimen, Courtenay Latimer's description, and his own anatomical analysis. What he did not have was a second coelacanth, and without a fresh, intact specimen with soft tissue preserved, the scientific community could only go so far. So Smith did something with no real parallel in natural history. He had leaflets printed, thousands, then tens of thousands, carrying a detailed illustration of the coelacanth and a reward offer for anyone who could bring him a specimen. He distributed them across the entire East African coastline and into the broader Indian Ocean fishing communities. Every harbour master, every fish market, every coastal village he could reach. If that sounds manageable, keep watching, because the scale of what he was up against gets considerably more daunting from here. The ocean he was searching covered millions of square kilometres. The fishing communities he was trying to reach spoke dozens of languages and had no particular reason to trust a South African professor waving money at them. The coelacanth, as Smith was beginning to suspect, probably lived at depth, somewhere between 100 and 400 metres, based on the body plan and the large eyes adapted for low light. That meant it would only appear in nets by accident, dragged up during deep water trawling operations that were not common in small-scale coastal fisheries. And then, in 1939, the world stopped cooperating entirely. World War II did not merely slow Smith's search, it effectively ended it for the duration. Scientific correspondence networks collapsed. Research funding evaporated. The shipping routes and communication channels he had been using to push leaflets outward across the Indian Ocean were redirected toward the war effort. The search went quiet. The years passed. The coelacanth remained singular, unreplicated, a single data point floating in an ocean of silence. By the late 1940s, more than a decade had gone by without a second specimen. The skeptics had begun to suggest that the 1938 fish had been exactly what the pessimists feared. A freak survivor, the very last of its line, a biological anomaly that had wandered into Goosens nets and died without leaving any descendants to be found. One fish did not make a species. One fish made a curiosity. Smith refused to accept it. The leaflets kept going out. The reward offer stayed open. And then, in December of 1952, 14 years after Courtenay Latimer's find and roughly 3,000 kilometres from East London Harbour, a second coelacanth surfaced. It came up near the Comoro Islands, a small archipelago sitting in the channel between Madagascar and the East African mainland. A local fisherman had caught it in deep water, and the news eventually reached a sea captain named Eric Hunt, who had seen Smith's leaflets years earlier. Hunt recognised the fish. He got word to Smith. What happened next sounds like it belongs in a different era of history entirely. And it does. Smith needed to reach the Comoros immediately, before the specimen deteriorated. The islands were under French administration, and the logistics of getting there from South Africa quickly in 1952 were not straightforward. Smith went directly to Prime Minister Daniel-François Malan and asked to borrow a government aircraft. Malan agreed. A head of state personally intervened to charter a plane so that a university professor could retrieve a fish. The specimen was flown back to South Africa on a military aircraft, packed in ice, and Smith reportedly wept when he finally held it. The second coelacanth changed everything in a very specific way. The Comoros find proved that the 1938 specimen was not a stray, not a freak, not the last survivor of a dying line. A population had been living in the deep waters around the Comoro Islands, completely undetected, for decades at minimum, and almost certainly much longer. The coelacanths had not merely survived the extinction event that ended the Cretaceous. They had built a life somewhere in the deep Indian Ocean and stayed there, invisible, while the world above them changed beyond recognition. The depth was the key. Smith and the scientists who followed him began to understand that the coelacanth's world was not the sunlit shallows where most marine biology happened. It was the steep volcanic slopes dropping away from island coastlines, the cold, dark water between 200 and 400 metres down, where pressure and darkness kept human observers away. The Comoros population had been there all along. Nobody had thought to look. That specific detail, the assumption that absence from shallow water meant absence from the ocean entirely, was a warning sign. The scientific community ignored it. Because if a breeding population of coelacanths could live undetected in the deep water around a known inhabited archipelago for the entire span of recorded human history, then the question was no longer whether other populations existed. The question was how many there were and where. A handful of researchers, in the years after the Comoros discovery, began arguing loudly that the Indian Ocean basin was far too large and too poorly surveyed for anyone to be confident the Comoros population was unique. They said the coelacanth's range could extend far beyond what anyone had mapped. Nobody listened. They were not looking for anything extraordinary that September morning. Mark Erdmann and his wife Arnaz were honeymooning in Sulawesi, Indonesia, wandering through the chaos of the Manado Tua fish market the way tourists do, half present, half distracted, taking in the smell of salt and the noise of vendors and the colour of a working harbour at full tilt. Then a cart rolled past them. On it was a fish unlike anything Erdmann had ever seen in an Indonesian market. It was large, heavy-bodied, covered in thick whitish scales with pale blue-grey spots. Its fins were fleshy. Its tail was three-lobed. He knew immediately what he was looking at. He grabbed his camera and took a photograph before the cart disappeared into the crowd. This was September 1997. The Comoros coelacanth had been known to science for nearly 60 years. Latimeria shalumni lived in the deep volcanic slopes of the western Indian Ocean, roughly 10,000 kilometres from where Erdmann was now standing with a camera and a racing pulse. There was no plausible migration route. The two ocean basins are separated by the Indian subcontinent and the vast shallow shelf of the Sunda region. The scientific community, when Erdmann reported what he had seen, was sceptical in the way that scientific communities are when something doesn't fit, politely, thoroughly, and with considerable force. The photograph was good, but not definitive. The fish had already been sold and eaten before anyone could examine it. The pushback was not gentle. He was told the fish was almost certainly a Comoros specimen transported somehow, or a misidentification, or a coincidence too large to take seriously. Erdmann could have stopped there. He didn't. He went back to Sulawesi. He talked to local fishermen, spread the word through the fishing communities around Manado, described the fish in detail, and asked to be contacted if another one appeared. He waited. He kept the photograph circulating. He kept making the case that the Sulawesi fish was real, that it was local, that the Indian Ocean was not as well surveyed as anyone wanted to believe. Then, in July 1998, 10 months after that market encounter, a second specimen was caught alive off the coast near Manado. This one was kept in a net pen, alive, for several hours. It was filmed. The footage shows exactly what the 1938 South African specimen showed: the slow, deliberate movement of those paired fins, the body rocking slightly in the current, the animal entirely unconcerned with the category crisis it was causing. It died before it could be transported to a research facility, but tissue samples were preserved. The genetic analysis that followed was meticulous and unambiguous. When researchers compared the DNA of the Indonesian specimen against the Comoros population, they found something that reframed the entire coelacanth story. The two populations had not diverged recently. The Indonesian coelacanths had been genetically isolated from the Comoros coelacanths for somewhere between 30,000 and 40,000 years. Separate enough, the analysis concluded, to constitute an entirely separate species. By 1999, the Indonesian coelacanth had been formally described and named Latimeria menadoensis, the second living species of a genus that the world had believed extinct for 66 million years, now confirmed to be hiding in not one ocean basin, but two. Let that settle for a moment. A fish that was supposed to have died out before the dinosaurs ended. A fish that science had already celebrated as the discovery of the century when it turned up off South Africa in 1938. That same fish, or rather its equally ancient cousin, had been sitting in the deep volcanic waters of Sulawesi for 30,000 years without a single confirmed scientific record. Local fishermen knew about it. They called it Raja Laut, King of the Sea. They had been catching them occasionally for generations. The knowledge existed. It just hadn't moved in the direction of the scientific literature. The discovery forced a reckoning that went beyond the coelacanth itself. 2 species, 2 ocean basins, both hiding in deep, remote, thermally stratified water, both sharing the same cryptic behaviour, nocturnal, cave-dwelling, largely motionless during daylight hours, resting in submarine caverns at depths where human survey effort had historically been almost non-existent. The scientists who had argued after the Comoros discovery that the Indian Ocean was too large and too poorly mapped for anyone to be confident the Comoros population was unique, those scientists had been right. Not because they had special knowledge of Sulawesi, but because they understood something fundamental about the relationship between survey effort and absence of evidence. 2 species had been sitting in plain darkness, at depths and in habitats that human beings had barely begun to explore. The Indonesian coelacanth hadn't migrated from the Comoros. It had been there, diverging slowly, for 30,000 years. The ocean had simply not been asked the right questions. A fish thought extinct for 66 million years, rediscovered in 1938, then found again in an entirely separate ocean basin 60 years later as a distinct species. Each discovery had expanded the boundary of what was considered possible. Each one had embarrassed the assumption that absence of evidence was evidence of absence. But here is the thing about boundaries. They keep moving. And the scientists who began mapping the full extent of the coelacanth's range after 1999, who started asking how many other deep and remote aquatic habitats had never been properly surveyed, had a very limited amount of time before that question would be answered in a way nobody expected. The coelacanth story wasn't finished, not even close. The scientific community had roughly 2 decades before the next piece of evidence arrived, and the clock had already started. There is a formal definition for extinction. The International Union for Conservation of Nature sets the threshold at no confirmed sighting of a species for 50 or more years across all of its known habitat. That is the line. Cross it, and the species moves into a category that carries enormous weight in policy, in funding, in the way we talk about what has been lost. But it is worth being precise about what that declaration actually is. It is a probabilistic statement. It is the scientific community saying, in careful language, that given what we have surveyed and how long we have looked, the continued existence of this species is unlikely enough that we are treating absence as fact. It is not a certificate. It is a best estimate. The coelacanth is the most famous example of what biologists call a Lazarus taxon, a species that reappears in the living or fossil record after a gap long enough that its survival seemed impossible. The name comes from the biblical resurrection, which tells you something about how these discoveries feel to the people who witness them. The Wollemi pine was believed extinct for 200 million years before a small population was found growing in a canyon outside Sydney in 1994. The Chacoan peccary existed only as fossils until 1975, when a living population turned up in the dry forests of Paraguay. The coelacanth itself carries a 66 million year gap between its last fossil record and Marjorie Courtenay Latimer's impossible fish on a dock in East London. Lazarus taxa share certain features: small populations, cryptic behaviour, habitat in areas with low human survey density. They were not hiding because they were clever. They were surviving because we weren't looking in the right places with the right tools. Think back to that first image, a fish being hauled onto a dock, heavy and strange, its fleshy fins still moving. The fishermen who caught it were not astonished. They had seen these before. The astonishment was entirely on the scientific side, because science had drawn a line and called it final. Absence of evidence is not evidence of absence. That principle sounds obvious when you say it plainly. It sounds like something everyone already knows. And yet, repeatedly, it fails to govern the way we make official declarations about what no longer exists. We didn't find the coelacanth because we got better at searching. We found it because someone happened to be standing on the right dock, on the right morning, and paid attention. The ocean didn't reveal itself. It just stopped being ignored for one moment long enough to show us what was there. What survived is the reminder that our maps of the impossible keep needing to be redrawn. Subscribe for more comeback stories that science almost buried.